15. Okay, so for number 15, while I'm writing it out, when you're solving something with factoring, when you're solving an equation with factoring, what was that first step that you're supposed to do?
Greatest common factor.
If you're factoring, but we're not factoring it. If we're solving something that is an equation, so here it is. I'm writing it out. X squared minus 3x. There's a few steps that are interchangeable, but there are a few that you really need to make sure you do first. What's something you need to do first? Yeah.
Make one side 0.
Make one side 0. So before you do anything, just make one side 0. There's a few things. You'll get better at it and do things in a slightly different order maybe, but you really have to make sure it equals 0 because the zero product property does not work unless one side is 0. So in this case, literally just, what am I going to subtract from both sides? I'll subtract the right. So minus x squared, and what do I add? 3x. So what do I end up with when I do this? X squared minus 12 minus what? Minus what? X equals 0. Does it equal 0?
Yeah.
It sure does. Did I copy it down right, Hannah?
Yeah.
It looked like she was checking. Okay, so now, is that in the right order?
Nope.
We like it going into highest power to the next highest. And now you try to factor it. What's the nice thing about that trinomial? What's the nice thing about that? You copied down wrong?
No, we did the whole section.
Oh, okay. What's the nice thing about that trinomial, Chris?
Leading coefficient.
Leading coefficient is what?
1.
1. Leading coefficient is 1. It breaks down nicely into x and x. What do the other two numbers have to multiply together to get?
-12.
And what do they have to add together to get?
-1.
So it's going to be
Negative and positive.
negative what and what?
-4.
And 3. You can test it. It does work. And if you do this, what's now the OR statement? You have two things multiplied together. What's the OR statement, Chris?
X plus 3 is equal to 0, and x minus 4 is equal to 0.
Yep, or he got to it. Or x plus 3 is equal to 0. So therefore x is equal to 4, or x is equal to 3. So you have two answers right here. There's actually one last thing you can always do if you want to, but I'm fine with this. You can go back in to the original statement, and what can you plug in? Your answers. You could plug in -4 and 3. You could plug in those two things. They should both work. There are times, we have not gotten to it yet, there are times when you will solve a quadratic or solve something involving quadratics where you will do all the math correctly, you will get an answer or 2 or 3, and one of them might be a false answer. It is possible there are some processes that sometimes generate extra answers. We're not there yet. You don't have to worry about it yet. Yes, Hannah?
What I did wrong.
What'd you do?
6.5 up here, but didn't put that.
Oh, it's okay. It's okay. It's all factoring, so it's just practice. So what's that first step?
One side equal to 0.
Yeah. The only modification I will say is you could multiply it out first if you wanted to.
Distribute it.
You could distribute first. I will allow you to do that. It sometimes makes the subtraction easier. So you could multiply it out and you get, I just moved the screen before I wrote. It's going to be 3x squared minus 9x plus x minus 3 is equal to 2 plus 3x plus what? 15. You can multiply it out first. That's okay. You just now have to, before you factor, this is a must. Before you factor, you must set one side equal to 0. You have to do that before factoring. So in this case, let's just subtract. How about we subtract 2 and 15, so we're subtracting how much? 17. Subtract 3x. So we end up with 3x squared minus 12x plus x minus how much?
17.
Well, there's 3.
-20.
Negative 20 equals what?
0.
Are any like terms present now? You see any like terms?
Yeah.
Yeah, what are they?
-12x.
Correct. So they combine, and what do you get, Chris?
3x squared minus 11x
Yep.
minus 20 equals 0.
So at this point, you might be a little bit dismayed because unfortunately the leading coefficient isn't 1. You want to say 0, I know, because it's invisible, but it isn't 1. But at least the leading coefficient isn't what? How could this be made even worse? Bigger number. At least 3 is prime and it's small, right? At least 3 is prime and small. So you really only have 3x and x. What do the other two numbers have to multiply together to get? -20. Now, one therefore needs to be positive and one needs to be negative. So you need to pick two numbers and just test. What two numbers do you want to try first? Hold on. What did you say?
Wouldn't one of the x's have to be -2?
No, it's all because the first term is 3x squared. This is positive. See, Megan?
Yeah, but couldn't both of them be negative?
They could, but we don't test that and you don't have to. They could both be negative, but that will never come up as a final answer. Like, for example, like, what is negative negative 3 equal to?
9.
No,
3.
3.
Oh.
Do we write it as negative negative 3?
No.
No, we just write 3. The point is you can do negative 3x and negative x, but it won't change the other ones. So the other two numbers have to multiply together to get negative 20. Is 11 a big or a small number? Relatively small, so we're probably not going to use a 20 in there. Like, it's not going to be 20 and 1, so what do we want to test? Maybe what?
2 and 10. 2 and 10.
10 and 2 and 10, maybe?
Oh, wait, no.
Where do we want to put the 10?
On the next to the x.
So,
Oh,
next.
To the 3x.
4 and 5, I know it.
I understand. I'm trying to. Okay, she's already tested it. Actually, an activity I used to do with my Algebra 2 classes is I'd pick some sort of. It would be like 16 is the first number and 32 is the second. So there was like 30 things to test, and I'd be like, you test this, and I have my little factoring farm.
I
pretty
just
fun.
know it because
I know.
3 times 5 is 15.
I understand. It's not going to be big. Yeah, I got it. So you want 4 and 5? Where do you want? So what's the first one you want to list? Negative.
4.
You want plus 4
Yeah, plus 4.
and minus 5. So test this. Test it. 3x squared minus 15x plus 4x minus 20. And is that what we want right here? Yay, it is. We're happy about it. What is the or statement now? Someone who hasn't spoken yet. What's the or statement? Someone who hasn't spoken yet. Someone. What's the or statement? Anybody? You already got it. Sure. You haven't gone yet.
3x plus 4 equals 0 or x minus 5 equals 0.
Please make sure you write down the or statement. I know it's really simple, but I can guarantee if you don't, you will double the probability that you will get something wrong. Which part are you confused about?
No, I'm not.
Okay. Okay, I'm glad I can help. I'm confused.
Wait,
Yay!
no.
Where? Which line? 1, 2, 3, 4, 5, or 6?
3.
Line
So
3?
When you do that, you don't have it so it's 3x plus 4 equals 0 and x minus 5 equals 0.
Yeah, that's what we have right there. There they are.
And then what did you
This
add
is
5?
right there. No, we're not done yet.
Oh.
We're not done yet.
Those
We're
were the
just
answers. I was like,
no. We're just saying we have the or statements. Now what do we do?
Then you, okay.
Now we solve them. What I'm saying is some people just try to do this in their head too much. And you know what's really easy to do? Like flip the sign of the answer, like saying 5 instead of negative 5, that kind of thing. So the final answer here would be those two numbers. And I would really like you to circle answers like that. I would really like you to circle answers like that. Got it? What can you go straight to?
The or.
Yes. So 3q minus 4 is equal to 0, or what? 2q plus 5 is equal to? So 3q is equal to 4, q is equal to 4/3, 2q is equal to negative 5, so q is equal to negative 5 over 2. That one's already factored and it equals 0, so you can go straight to the or statements. Gabby. This is not factored. Does it equal 0? So we need to make it equal. So let's make it 2x squared plus x minus 3 equals 0. I subtracted 3 and I added x. You with me so far? So at this point, we do have to factor it. The leading coefficient isn't 1, it's 2. What does that break apart into? 2x and x. The other two numbers have to multiply together to get what? Negative 3. So any idea about how you want to break this up? So it's either 3, it's going to be 3 and negative 1 or 1 and negative, like what do you want to test first?
Negative 3 and 1.
Yeah, let's try negative 3 and positive 1. Minus 3 and? So if we need to test this. It's really easy to look at and be like, oh, it's right, and not be right. If I multiply this out, I end up with 2x squared plus 2x minus 3x minus 3. What do I end up with?
Negative 1.
Do I end up with the right thing? No, I don't. Don't erase it. Just try again. So we'll keep the 2x and the x. What do you want to change?
3 and 1.
Not the, you want to change the,
Sign.
change the sign. Make it plus 3 and minus 1, because what's the only thing that's wrong there? If the sign is the only thing that's off, just switch the sign. Equals 0, let's test it. 2x squared minus 2x plus 3x minus 3. Do we end up with the right thing? We do end up with the right thing. So what's the or statement? Someone who hasn't spoken yet. Sarah, what's the or statement going to be now? You have two things that multiply together to get 0. The green thing and the purple thing. You have two things that multiply.
2x plus 3.
So 2x plus 3 has to be 0, or what's the other one that could be 0?
Oh.
What's the other one? Done. You got to finish it, You have to solve both of those. Are you okay solving those? Yeah, so 2x equals negative 3, x equals negative, or x is equal to
I'm just like
1.
confused why do the or statement.
The or statement because we want to solve it.
But if none of them equals 0.
Ah, that's why you have to make it equal 0 to begin with. The process is like make it equal 0, then factor.
Like I get how to do it, but I don't get why there's just 0 just chilling.
Because we forced it to, so this one was set up like this. This is the original problem right here. You see this? Does it equal 0? No, so we made it, we rearranged it. How did we rearrange it? We subtracted 3 and we added x. And what did we end up with? The thing in the red. These two things are the same equation. They have the same solutions. But we made it equal 0 specifically because we have this zero product property, which states that if A times B equals 0, then A or B, well, or both, right? It is possible, must be what? So what it allows us to do is we get to take this thing, see the red box? That's relatively complicated. We rearrange it. This right here is still the same thing, but we have two things that are multiplied together, the green thing and the purple thing. When multiplied together, they equal 0, so one or both of them has to be 0. So we say, okay, this one has to be 0, or this one has to be 0. When is that true? Negative 3/2 or 1. Gabby, please. You could take these two numbers and plug them in right there. You could check that way. You absolutely could.
1 next to 1 and then 1 to the other.
No. You do take 1, plug it into everywhere here, and is it a true statement? What's 2 times 1 squared? 2. What's 3 minus 1? 2. So is it true? Yes. You do the same thing for negative 3/2. Do it a little carefully because it's a fraction, but it should be a true statement. These are solutions because they make this equation true. Is 5 a solution? Why not? It doesn't make the equation true. If you plug 5 in, 5 squared is?
I thought you were saying in general, could it be
Oh.
a solution? Like I was like, yeah.
Well, not in this one, but it could be somewhere else. Like suddenly we're shunning the number 5. Arbitrarily just like shut numbers out. I get it. Chris and then Noah.
What if
End up with, you do a lot of work, and then you might end up with both, like x minus 5 equals 0. It is possible, or x minus 5 is equal to 0, because you could have x minus 5 times x minus 5 equals 0. Well, in this case, x equals 5 or what? So can you have the same number? It's just one answer? Yes. Here's the reason why you can get that. You want to see the visual reason? No, it has to do with what the graph looks like.
Oh.
What does the shape of a parabola look like? Use your arms. What's it look like, everybody? It looks like this, or it goes down. It's a U shape, right? So here's the thing, everybody. Here's a parabola going up. It's going up, right? The x-axis could either not intersect it twice, or it could intersect it how many times? Once. So how many numbers of solutions could you have?
3
You could, no. You could have 2 solutions,
or 1.
or 1 or none. There are quadratics. Where you factor it, and it doesn't have any answers. We haven't gotten to those yet. But you can have two answers, 1 or what? None. If I asked you, where does the black parabola intersect this bottom red line? You would say, it doesn't. So if you try to find out where they intersect, you're going to run into something like 5 equals 7. Is that true? No. If you try to find where two things intersect when they never intersect, you're going to run into some sort of contradiction. First thing you have to do is you have to figure out what's the smallest number that number divides into, reading from left to right. So what's the smallest number? 12. How many times does 12 go into 12? 1. When you put the 1 up top, what do you do with it? You then multiply this by that number, and you end up with 12. And then what do? You subtract. You always subtract. And I want you to get into the habit of putting a parentheses around this. Just watch. Don't do it now. Just watch. If I subtract 12 from 12, what do I get? 0. And then what do I drop down?
3.
The 3. How many times does that go into there?
0.
0 times. It goes in 0 times. 12 goes into 3 0 times. So then 0 times 12 is? 0. When I subtract this, putting the parentheses around, what's 3 minus 0? 3. And then what do I drop down?
Bring down the 4.
4. How many times does 12 go into 34 without going over? Twice. And then what do you do with that 2? You multiply and you get 24, and then you subtract parentheses, leaving you with 10. What do I drop down? The 5. How many, kids, how many times, Verdi, does 12 go into 105 without going over? 8. You do 8. 8 times 12 is? 96. You subtract and you end up with? 9. What do I drop down now? 6. And how many times does 12 go into 96? 8 times. What's 8 times 12? 96. You subtract and you end up with? 0. So what does this tell us? It tells us that 123,456 divided by 12 is what? 10,288. How would you check to see if this is correct? Can you shut the door, please? You multiply what by what?
10,288.
Yeah. You do the multiplication. You would do 10,288 times 12, and you'd hope that it comes out to 123,456. It does. You got it right. My question to you now is what are the terms for each? What are the names for each of these terms? There's the green term. Don't say them yet. The blue term, and I'll say the yellow term right there. What are the names of each? Is equal to 927 plus what? 3 over 7. Plus 3 over 7, not plus 3. The remainder is 3, but the actual answer will be 927 plus 37. So if you had to rewrite it, that's what it means. If I ask you for what the remainder is, you would say the remainder is 3. But the answer, what does this tell us? It tells us this right here. You used to do this. You used long division. Correct? I might ask you, and what are you going to use to solve that one? Something long division. It's a kind of long division. Good guess. That's a great guess. What are both of those things that are on the top and bottom?
M's.
Their M's are involved, but
It's
Expressions.
polynomial.
yeah. So we need to learn, and it's really important that you really pay attention to this because you probably have never seen anything like this before, polynomial long division. The key to polynomial long division is 2 things. The first thing is similar to regular long division. It's similar to regular long division. The second thing is you need to remember this phrase because you're going to use this phrase over and over and over again, which is everything
Times everything.
over everything. That was good. Everything over. I can't believe I emphatically just told you the wrong word. Leading
Oh, that's why, see?
over leading. And I can't even spell it. Leading. There we go. This is important. So watch. You really just need to watch. Don't be twitching. Don't be taking notes. Just try to watch this. It's really important. So you're going to set it up just like you would set up a long division problem. So what am I going to write down first? What goes to the left? 11 minus 2. M minus 2.
Yeah.
We have M minus 2. And then what am I going to write underneath that little division thing? Yep. Plus M minus 10. So the first thing we did when we were doing long division was we looked at what's the biggest number we can divide into. Similarly, you're going to do something just like that where, what's that phrase right there at the top? Read it out loud. Leading over leading. What's the leading term underneath the division symbol? 2m squared. What's the leading term for the divisor? M. What is 2m squared over m?
2m.
Where do you think you put that 2m?
Under. 2m.
Up top.
Yeah.
You put it above what it corresponds to. Every time you wrote a number up above the division sign, what did you do with it next?
Subtract.
Nope. What did you do before? Multiply then.
And then subtract.
So I'm going to multiply 2m. What's 2m times m? 2m squared. What's 2m times negative 2?
4.
Minus 4m. So you just did the multiplication, Sarah. What did you say you needed to do next?
Subtract.
So yes, and remember how I told you I want you to put those parentheses around? That's why it's super important, because you're subtracting everything. What's 2m squared minus 2m squared?
0.
It cancels.
It cancels, and that should happen. That's the whole point of doing the division first. Can someone tell me carefully, be careful, what's left? Someone raise their hand when they have it. What's left, Sarah?
Negative.
M minus negative 4m. Minus a negative is
No, it's 2m squared minus.
no multiplication.
5m.
M minus negative
Oh, yeah,
4m.
yeah.
What is it going to be?
5m.
5m. Okay, what was that phrase again?
Would it be possible to?
Distribute it? Yes.
Yes.
But you can, what I'm highly recommending, just put the parentheses in there and stop doing that. Just do it that way.
Okay.
You see the parentheses I put in there? I can guarantee everybody at some point is not going to put the parentheses in, and then they're going to do minus 3m.
Okay.
And you'll get really frustrated because it just won't work.
Okay.
So now we're at this point, what is the leading term? The zero is invisible. What's the leading term now? 5m. Oh, what did the leading term stay over here? This never changes. What's the m? What's 5m over m?
5.
What do we put up top?
5.
So it's plus what? 5. So 5 times, now you multiply 5 times m is
5m.
5m. What's 5 times negative 2? Oh, I can't write that, negative 10. And you can drop this down now because you're going to be subtracting. If you subtract, what do you get? 0. Hey, this right here is going to make you happy whenever you see it, because when you have a remainder of 0, what does that mean about the division? No, you can have a remainder and do it right.
It wasn't right.
It wasn't right over there, but that's because you had something to compare it to. No, when you have a remainder of 0, what does that mean about the division?
Stop.
It divides evenly. Like how many times does 2 go into 8? 4 times evenly, because there's no remainder. What does this tell us, everybody? It tells us that 2m squared plus m minus 10 over m minus 2 equals what? 2m plus 5. That's what we just figured out. We just figured that out. Now, are you always going to have a remainder of 0? No. Right now, another way you could write this is plus 0 over m minus 2. But what do we write that as? That's just what?
0.
That's just 0. That's just 0. If it wasn't, you would have to write it in,
Okay.
depending on what I'm asking you to do. I might ask, what's the quotient, or what's just the remainder, that kind of thing.
Those two that we got, what you divided by and then the quotient, those are the two, that's how you factor.
Ah, look at that. You just made the key realization here. So this is 0, right? How do you check this? m minus 2 times 2m plus 5. We want to know, does that indeed equal 2m squared? Hey, have we had some practice doing this kind of process before? We just figured out another way to see if it factors nicely. The division will tell us if it factors nicely. And just to put this in perspective, it's not just this class that long division of polynomials will be useful. If you take pre-calculus, you will definitely do polynomial long division, and in AP Calculus, and in lots of other math classes. So another one. Let me do another one. Let me pick a good one for you. How about, let's introduce this one. Let me pause it. I wrote that very particularly. I'm adding a negative. I added a negative on purpose, and I put a space in there on purpose. Can someone tell me why I put a space there? What's missing?
I was going to say, so you don't like distribute it.
So one way is like maybe keep track, but I put a space there because there's a term there that's missing, meaning that it's just invisible. Can someone tell me so we have 3x cubed minus 2x plus 5. What term could theoretically go in between? X squared, but is there an x squared?
Yeah.
This is something that usually I let you guys do it and you'll do it wrong for like 20 minutes and then I'll show you how to do it right. When you're doing long division, you need to set it up so that all of the powers are present. So what am I going to add right here?
0x squared.
Have I changed anything by adding 0x squared? What is 0x squared?
0.
This is just a placeholder, everybody. This is just a placeholder that makes everything line up nicely. Does it change the overall question? No, it makes it easier to line things up. What was that phrase I taught you to remember? Leading over leading. So what's the leading term underneath the division? 3x cubed. What's the leading? This always stays the same. X, so what's it going to be? 3x. Where do I put that? Oh, right here. Once you put it there, you have to multiply. So you get 3x cubed minus what? 9x squared. At this point, what do I draw in? And what operation am I doing? Minus. So is it good that that's 0? Yeah. Can someone tell me raise your hand when you can tell me what's left. Careful.
9x squared.
9x squared. Why is it positive 9x squared?
Because
because it's okay. No, you got it. You got it.
Whenever I raise my hand.
I know. I'm sorry. She didn't raise her. It's fine.
It's just because I
Here,
got it.
you got it. I heard the emotion. It's good. Minus a negative is a positive. Now what do I bring down? Oh, I actually don't. I'll bring down a. You can bring it down now. But what's the leading term? What's the leading term now? 9x squared. It's the other one stayed the same. So what am I left with? 9x.
Minus 2x.
Well, no, hold it. You just do leading. You just do leading. I'm just putting it there just to remember it. 9x. Oh, you get 9x squared minus what? Nope. Minus. Nope.
Oh, 0.
Nope.
27.
27x. It's this times that and this times that. Everybody see it?
Just the leading time?
Just the leading. You do whatever you just put up there. Yes, whatever you just put up there. So in this case, it was 9x
Got it.
times x and 9x times -3. You get this. What do I put in?
Parentheses.
Please put those parentheses in. And what do I do? What operation?
Subtract.
So I get 0. That's nice. Can someone raise their hand and tell me what's next? Hannah.
29.
No.
5.
Plus 25x.
25x plus 5. What's the new leading term? So we have 25x over x equals what? 25. So I put plus 25. 25 times x is? Okay, that's what it should be. 25 times -3.
Negative 75.
When I subtract this, what do I end up with? What do I end up with?
0.
Nope.
80.
Yeah.
5 plus 75 is? 5 plus 75 is?
80. I said 0 plus 80. I was going to say
Oh, 0 plus 80. You centered it. I see.
Yeah.
Now, do we go? Now, this is the big question. Do we go any further?
No.
No.
When we did regular division, when did we stop?
When
When
the
the-
smaller.
When this was smaller than that, right? But over here, what do we have? An x and an 80. You stop when the degree of x is smaller than the degree of x up here. What's the degree of x here?
0.
The degree of x is 0 here. The degree of x is 1. So we stop.
What does that mean? What-
Is there an excess?
oh.
So here, I could write it like this, Sarah. I could say this is 80x to the 0, right? Stuff like that. So if you were to tell me about your answer here, what's the you now know that 3x cubed minus 2x plus 5 over x minus 3 is equal to what? 3x squared plus 9x plus 25 plus what?
80
Plus
over
80 over.
x minus 3.
Yes. Does this factor nicely?
No.
Why not?
Not evenly.
It's not evenly divisible. The remainder is not 0.
Yeah.
So you can use this as a way to test to see if it is factorable nicely. And in this case, you're like, no, at least not with this factor. It tells you that x minus 3 is definitely not a factor. Could there be a different factor? Sure. Like, for example, 7, does it go into that number evenly? No. But are there other numbers that go into I was like, yeah, darn. 7 doesn't go into that one evenly. Are there others that it could go in? Are there other factors? Like 2? Yes, there are. There are. The way you do this, everybody, there are great examples in your book. There are great examples. You need to take it very carefully, though. Look how many different places you could make a small mistake on this. Flipping a negative instead of a positive, all sorts of ways, right? It's not super fun. It's not super fun.